Hello and welcome to today's lesson on velocity time graphs. So in today's lesson we're going to look at how to construct and analyse velocity time graphs, which is part of the GCSE Combined Science course for forces. So this is going to be in the AQA GCSE Combined Science section for physics. So what are we going to look at in today's lesson? Well, we're going to look at firstly defining what velocity is, describing in both words and mathematics what acceleration is, and then look at how to construct velocity time graphs and then interpret them. So it links into the following part of the AQA Combined Science specification. So it falls into the velocity aspect and the acceleration aspect. And you'll notice in the acceleration aspect of the specification, there's a number of bits on this particular part of the specification where it's higher tier only. So we'll investigate all the different parts in today's lesson. So, what can we do? Well, we can show how a velocity changes in a journey with the velocity time graph. Now, in these graphs, you put velocity on the y-axis and time on the x-axis. So, as a question, what would the gradient of this graph represent? Well, quite simply, it would represent the acceleration, because the gradient is the change in y over the change in time, so it's the change in velocity over the change in time, and we call a change in velocity over time an acceleration. So the gradient of the line in the velocity time graph indicates the acceleration. Now, if the object is changing its rate of acceleration, the line of a velocity time graph will be curving. Now, if an object is changing its rate of acceleration, you can then determine the acceleration at a particular time by drawing a tangent and measuring the gradient of the velocity time graph at that particular point. So a tangent is a straight line that touches the curve at a point, but if extended, doesn't cross at that particular point. So in this example, we've got a tangent to the graph at 10 seconds. So it's a straight line, just touching the graph at the 10-second juncture. And then, to work out the gradient of the tangent, you draw a gradient triangle, then repeat the same calculation as you've done previously for gradients. The change in y over the change in x. Now, this gives you a velocity time graph that can look like the following. Now, there are 4 different sections on a velocity time graph that you've got to be aware of. Now, the first part is the constant acceleration. Now, if a line has a gradient upwards, it must be constantly increasing its velocity, so therefore it has a constant acceleration. If the line is flat, then the velocity is not changing, it's staying at the same value, so it must have a constant velocity, it's maintaining the same velocity. Now, an object will only be stationary when there's a flat line along the x-axis, because that will give a constant velocity of 0. But if the flat line is not on the x-axis, it's not stationary, it's maintaining the same velocity. Now, if the line has a constant gradient downwards, it must be constantly decreasing its velocity, so we say the object has a constant deceleration. And finally, if the line is below the x-axis, this means the object must have a negative velocity. Now, a negative in a vector term, like velocity, means that the object is traveling in the opposite direction. So this means if you calculate the acceleration of an object just mathematically and it's negative, it could either be a deceleration, so a slowing down of velocity, or it could be an acceleration in the opposite direction. It could be going the other way to the previous part of the journey. Now, the only way to work out which it actually represents is either you've got to look at the velocity time graph, or in the real world, you would look at the object as it's in motion. Now, in the previous tasks, we've used the word acceleration. Now, it's a word that tends to come up a lot in the everyday language. But what does acceleration mean? How to calculate acceleration? What are the units of acceleration? And what causes acceleration? Well, acceleration is a change in velocity over a certain time. Now, we know a velocity is both a speed and a direction. So an acceleration can either be a change in speed or a change in direction. Now, acceleration, like velocity, is a vector quantity. It has a direction part of it. Now, we can calculate acceleration by the following equation. Acceleration is the change in velocity over the time taken for that change, Or we can say that the change in velocity is the final velocity, the end velocity, minus the initial or starting velocity over time taken. Now, these are both the same equation written in different ways. Now, this equation needs to be memorized for your examination. It's an equation you've just got to learn. Now, as acceleration is a change in velocity, which is meters per second, divided by a time, which is in seconds, well, the units of acceleration are therefore going to be meters per second divided by seconds. So it's meters per second, or meters per second squared. Now you can write it as one of either three ways. m/s/s, now a slash just means divide, m/s squared, where it means that there's two values of the s, or ms to the minus 2, because you can replace a slash in a unit with a negative indices. So that slash s squared becomes s to the minus 2. Now you will pronounce any of these interpretations of the unit, which can be written in any way, as meters per second squared. Now, a fundamental rule of physics states that an acceleration, so either a change in direction or a change in speed, is caused by a resultant force. No resultant force, no acceleration. That is Newton's first law of motion. An object will only accelerate if there's a resultant force placed upon it. If there's no resultant force placed upon it, an object will continue to move with the same speed in the same direction. It will have inertia. Now, so as we mentioned before, a velocity is a speed with a direction. So if you change speed, you accelerate. So if an object changes speed, it's changing velocity, it's accelerating, and you will require a resultant force to do this, which is the most commonly thought of method of acceleration. When you say someone's accelerating, you tend to indicate that they're changing speed. Now, a negative acceleration could be a decrease in speed. Now, but you could also accelerate by changing direction, because velocity is a speed with a direction. If you change direction, you accelerate. Now again, it requires a resultant force to do this. Now, a negative acceleration in this instance could be the object moving in the opposite direction. Now, you would only know what it's talking about, either moving in the opposite direction or slowing down, by looking at the information in the question. Now, to produce either a change in speed or a change in direction, a resultant force is needed. Now, like we just mentioned previously, to work out the acceleration from a velocity time graph, you would do the gradient, because the gradient is the change in y over the change in x, so it's the change in velocity over the change in time, which is the acceleration. But your velocity time graph also includes a little bit more information, because the area under a curve for a graph is the y-axis times by the x-axis. So the y-axis is velocity and the x-axis is time, so the area under your curve is velocity times by time. Now you know that velocity, okay, is a change in distance or displacement over time, so therefore, okay, the velocity times by time is going to be the distance travelled. So basically, the area under a curve of a velocity time graph is the distance travelled by that particular object. Now, to calculate the area under the curve, the distance travelled, what you tend to do in a question is you split up the shape under the curve into triangles, rectangles and squares, and then you can work out the area of these shapes and then add them all together to work out your total area. So, for example, in this particular situation, you would split the shape up into squares and triangles. You'd then work out the area of your square, which you know from mathematics is length times by height. You'd work out your area of your triangle, which you know from mathematics is a half length times by height. And therefore, to work out the total area under the curve, you do your area of your triangle plus your area of your square. Now, here's an example question we can work through together. So the question might ask you to work out the distance travelled by this object in the journey. So the first thing you do is separate your area into rectangles and triangles. Okay, you work out the area of the rectangle, which is height times by base. So in this instance, the height is 10 and the base is 12 minus 4, which is 8. So it's 10 times by 8, which is 80 meters. You then work out the area of the first triangle, so we know it's a half times by height times by base. What's the height? It's 10. What's the base? It's 0 to 4, so it's 4. So a half times by 10 times by 4 equals 20 meters. You then work out the area of the second triangle, so a half times by height times by base. So it's a half times by the height, which is 10, times by the base, which is 14 minus 12, which is 2. So it's a half times by 10 times by 2, which is 10 meters. You then add up the three values together, 20 plus 80 plus 10, and you get your total area to be 110 meters. So again, this is another example of a question they could possibly ask you. So when you're trying to work out the area travelled by an object, so the area under the curve, which is the distance travelled by the object, you split it up into a rectangle and a triangle, you then work out the area of each, you add them together. Now, if we look at this particular situation here, we can get velocity time graphs which have a negative section. Now, what does that mean? What would a negative section mean for the object? Well, a negative section we've talked about previously means the object starts to move in the opposite direction. So basically, the distance moved in one direction will be on the positive part of the axis, and the distance moved in the opposite direction will be in the negative part of the axis. So if we now consider this in terms of displacement, one area will be the positive displacement, the distance moved in one direction, whilst the area on the other part of the curve will be the negative displacement, the distance travelled in the opposite direction. Now, if there's a negative section, how would you work out the total distance travelled? Well, the total distance travelled will be area 1 plus area 2, because distance is a scalar. So there's no direction attached to distance. Distance is just the total amount of movement you have done in the journey. So therefore, even though area 1 and area 2 represent different directions, that does not matter when you're working out distance travelled, as it's a scalar, so you just add the two values together. But what if you wanted to work out the total displacement of the journey? Now, displacement is a vector. Displacement includes the direction of your motion. So therefore, now, to work out your total displacement, it'll be the areas subtracted from one another. Now, in this instance, I've said area 1 minus area 2. It could be the other way, depending on what the question is asking you. But because we're now considering distance and they're traveling in direction, and now traveling in opposite directions, you've got to subtract one from the other, because one has a positive direction and one has a negative direction, which is why in a journey you can have a value for distance but no value for displacement if an object has gone back to where it starts, because the positive and negative aspects of the journey will cancel out in displacement, but they would have no effect on distance, they would only be added. So, what have we learned in this particular lesson? Velocity is a speed in a given direction, and acceleration is the change in velocity per second. Okay, and the unit of acceleration is meters per second, or meters per second squared. The average acceleration of an object can be calculated with the equation acceleration is equal to change in velocity over time taken, and the deceleration is the change of velocity per second when an object slows down. The acceleration of an object can be calculated from the gradient of a velocity time graph. Now, the distance travelled by an object or the displacement can be calculated by the area under velocity time graph, which is a higher tier only skill. And then you should be able to draw velocity time graphs for measurements and interpret the lines and the slopes to determine acceleration, interpreting closed areas in velocity time graphs to determine the distance travelled or the displacement for higher tier only students, and then where appropriate, calculate the area under velocity time graph by counting squares, which again is for higher tier only students. So, hopefully you have learned those following aspects for today's lesson. I hope you've enjoyed this lesson on the velocity time graphs, acceleration and velocity. Have a lovely day. Thank you.